let's do one more example of a full two-sample hypothesis test. So in this scenario, we have a baseball team's pitching coach being concerned that his team star pitcher is losing speed from his fastball. He measured the speed of 20 random fastballs thrown by the pitcher during spring training and compared it with the sample of 20 random fastballs thrown during the pitcher's last 5 starts in the prior season, in miles per hour. The results are on the second tab in the two-sample testing data spreadsheet, which I have open over here. Assume that the speeds for both time periods are normally distributed and that the population variances of the fastball speeds are equal. We want to run this at a 0.05 significance level to see if there is any evidence that the pitcher is throwing fastballs at a slower speed using Excel. Okay, so let's see. We've got to check our conditions first. It does say very clearly here that both of the samples are taken randomly. There's no one-to-one correspondence or any sort of a relationship really between the fastballs during spring training and the fastballs during the last 5 starts. So they're independent samples from each other. They were taken at 2 completely different times, so they are independent. And we are told the sample sizes are only 20, so they don't hit the sample size requirement, but we are told that the speeds for both time periods are normally distributed. So we have that. So we do hit all 3 of our criteria. And so now we're going to get ready to write our null and our alternate hypothesis. We're interested in whether his speed is slowing down or if the speed is becoming less. But with the ordering that we have spring training first. So notice spring training would be mu of, I'm going to call that mu of ST. And then we have mu of the last 5 starts. So I'm going to call that L5 for last 5. Now, if his speed is slowing down, notice that I would actually need to use a greater than symbol here. So be very, very careful with the wording. It's not always just totally straightforward. Write them down. Write down the 2 different population means that you have in order, and then decide which symbol is appropriate. So if I'm trying to find that they are now after the second one is lower, I actually need to use a greater than symbol. Okay, so then I can write my null as mu sub ST is less than or equal to mu sub L5. Okay, we are performing a one-tailed test in this case. That will become important when we look at for our p-value. We'll need to remember that. And also important information is that we are told the population variations of these fastball speeds are equal. So when we choose what type of test we're running, we're going to choose the equal variance option. Let's go ahead and go now into Excel. We're going to, again, we have our last year's and this year's. Okay, we are going to go into the data option and data analysis. This time we need to choose 2 sample assuming equal variances based on what we're told. Notice that everything in here looks the same though. So everything we do now is the same. We put in our first range. So last year versus, this says this year fastballs, and the question said the last 5 games. So this is what we want to use. I feel like the heading there might be a little bit mismatched, but at any rate, this is the second list of data, the second data set that we have. We hypothesize that perhaps there is no difference whatsoever between the means. I do have labels in the first row, so I'm going to click that. The alpha value of our problem is still the standard 0.05, so I don't need to make a change there. I'm going to choose the output range and just click somewhere over in a blank cell to give it somewhere to give me this information, and then click OK. And widen that up a little bit so that I can read everything clearly. Okay, so remember what we really want here. And notice, I mean, we can go back and check. Look, the average of the first sample was 92.2 miles per hour, and the average of the second sample was 91.4. So for these samples, the average speed did go down, but not by very much, and the variances are actually almost the same. So that was definitely the correct option there, was saying that these have equal variances. But the information we really want to take from here is this t-value of 1.291. And because we were doing a one-tailed test, we are using this p from a one-tail, which is 0.102. So I'm going to go ahead and pull my paper back up here and write that information down. So we got a t-value of 1.291, I believe. Yes, to 3 decimal places. And we have a p-value of approximately 0.102. So in this case, p is then greater than alpha, because this would be greater than 0.05. So we fail to reject the null hypothesis in this case. There is not enough evidence to conclude that the pitcher's fastball speed is declining. So again, from the samples, we did see a very, very small decline. But what this is saying is this decline, the difference between these is not drastic enough to say that for all fastballs that he has thrown, that there really is any difference at all. There's not enough, or that there's been a decline. So again, had we taken a different sample of last year's and a different sample for this year's, perhaps they were equal, perhaps actually, the second one might even be higher. So these are really just too close together to offer any real evidence of a decline. That's the situation that we have when we fail to reject.